Okay, so as in the last video, we have discussed about the maximum velocity and the minimum velocity of the motion in the elastic restoring force, or you can say Hooke's law or mass spring system, right? And before that, we derived the formula for calculating the velocity of the mass spring system, which came out to be omega under root x naught square minus x square. This was the general formula, right, which we got uh, in the motion of a projection of a particle along uniform circular motion. With help of this formula, we just derived the formula of velocity of the mass spring system by substituting the value of omega, which we calculated by comparing both formulas of acceleration which we got from the connection of uniform circular motion and the simple harmonic motion, and the acceleration of mass spring system. We compared these both formulas and we have got the value of omega, which is under root k by m. We just substituted this value in the formula of velocity, um, which now is under root k by m into under root x naught square minus x square. With the help of this formula, we have found our maximum velocity formula and the minimum velocity. We have known that minimum velocity we're gonna find at the extreme position. So at extreme position, we know that our x is equal to x naught, which is amplitude, which is the maximum displacement from the mean position to the extreme position. By substituting x as x naught, we got the value of velocity as 0, which is the minimum velocity. Then we found the formula for finding the maximum velocity as well. We just put x is equal to 0, since we know that maximum velocity we can find at mean position. At mean position, our displacement would always be 0. So we have just put x is equal to 0, x naught square cancelled with under root. Now we have got x naught under root k by m. In today's video, what we are going to learn, we are going to discuss about the energy of the mass spring system, right? Since energy is also included in this, we have not discussed about energy in the uniform circular motion and the connection of that with simple harmonic motion, right? But here in today's video, we are going to discuss about the energy of the mass spring system. Okay, so what we are going to discuss today is we are going to discuss energy of mass spring system, right? So now we are known that we have two type of energy, right? We have two type of energy. The one is kinetic energy and another one is potential energy, right? So we have two types of energies. We have two type of energies. The first one is kinetic energy. Kinetic energy. And another one is potential energy. Potential energy, right? Kinetic energy and potential energy. See, what's the form? We are just going to discuss today about kinetic energy of the mass spring system today. In the next video, we're going to discuss about potential energy of the mass spring system. But in today's video, we are going to discuss about kinetic energy of the mass spring system. Now, see, why do we possess kinetic energy? Kinetic energy is due to the motion of the body. It is produced when we have motion in a body, due to motion in a body. When there is a motion in the body, which means that body has kinetic energy, right? So motion of a body is responsible for what? It is responsible for the kinetic energy of the body. And we know the general formula. See, we are going to drive every formula with the help of general formula. So general formula of kinetic energy is what? the general formula of kinetic energy, everyone knows, 1 over 2 mv square, right? This is the general formula for finding the kinetic energy of any body. This we're going to learn in very detail how we have got this formula in the motion in 2 dimension, right? Initially motion in 1 dimension, then motion in 2 dimension, but this we're going to learn in motion in 2 dimension, right? So kinetic energy is equal to 1 over 2, which means half mv square, right? Kinetic energy does not depend on the velocity. It doesn't depend on the velocity, it depends on speed, right? It depends on speed. This is very important point. You must make a box and make a star on the top of it, since this is very important point. It depends upon the speed. Depends upon the speed, not velocity. It doesn't depend on the velocity, it depends on speed, right? This is very important point, right? Very, very, very important point. That's why I made a star 2 on the top of it, which represents, actually it is very important point, right? So it depends upon the speed, not velocity. Now see, we have already found the velocity of the mass spring system. We just need to substitute the value of the velocity in this general formula, right? So what we are going to do today, we are going to substitute velocity in kinetic energy formula. We are going to substitute the value of velocity in the kinetic energy general formula. Kinetic energy formula. And what is the velocity of the mass spring system? This we have already discussed in very detail, right? What was it? V is equal to, I should make this, right? So V is equal to omega square. Instead of omega, we have got in the mass spring system as under root k by m, right? Under root k by m into under root x naught square minus x square. In the case of maximum velocity, we have got under root k by m into x naught. In the case of minimum velocity, we got 0, right? So this is the general formula for finding the velocity of the mass spring system. Now we need to substitute this value of v in this general formula of half mv square. So using this formula again, ke is equal to half mv square. Let's substitute the value of v in this formula. So kinetic energy is equal to half m, instead of v, under root k by m into under root x naught square minus x square and whole square too. Since we have half mv square, so we have entire v square, right? That's why we have put entire v square, right? Now we need to simplify it. So kinetic energy is equal to half into m, which is this m, into, when square will gonna go on this, right? This square will be cancelled with this under root, so we have now k by m. This square would be cancelled with this under root, so now we have x naught square minus x square. X naught square minus x square, right? Now see, this m cancelled with this m, wait for it, this m cancelled with this m, right? So what we have got now is wait for it, kinetic energy is equal to half k x naught square minus x square. This is what we have got now, right? This is the formula for finding the kinetic energy of the system, of the mass spring system. Kinetic energy of mass spring system. Mass spring system. And where we're gonna have kinetic energy maximum, we're gonna have maximum kinetic energy at the main position. Max at mean position. And where we're gonna have minimum kinetic energy, minimum kinetic energy we're gonna find at extreme position. Minimum at extreme position. Right, so what we have got today, we have started the energy of the mass spring system, in which we have derived the formula for finding the kinetic energy of the mass spring system. In the next video, we're gonna derive the formula for the potential energy of the mass spring system, right? Potential energy by the average force. So we're gonna look into it in the next video. This was all for today.